So sometimes you're given the quadratic in what's called standard form for polynomials, which is not to be confused with standard form for quadratic. Standard form for polynomial is just the highest power of x, the next power of x, the next one. It's all multiplied out instead of in that form that we had on the previous video. So this one says graph y equals negative 3x squared plus 6x minus 1. So for this, we're going to have to go through more steps because we have to put it in the standard form for quadratic, which is the form we had on the previous page, where you can read off the vertex. So anyway, the problem says find the vertex, axis of symmetry, and the x and y intercepts. Also find where the maximum value is and what the maximum value is. So there's two different things. Where the maximum value is the x coordinate. And what the maximum value is the y coordinate. And when you graph this, you'll find that those two values will be actually where the vertex is. So in a sense, it's asking you to find where the vertex is. You just have to know which is the answer to where it is and which is the answer to what it is. Okay, so I have to complete the square on this because that's the form that we need it in to read off the vertex, the form I had on the previous video. So first, the leading coefficient is not a 1, it's a negative 3. So the first thing I need to do is factor the negative 3, and I'll just factor it out of the first two. So I factored the negative 3 out of the first two terms, and you get, I use square brackets because there's parentheses in a later step. So I put square brackets around what's going to go in here. And then what goes in here is just the original divided by what I factored out. So it's negative 3x squared divided by negative 3 is x squared. And 6x divided by negative 3 is negative 2x. Okay, so that's the best way to think about that, is divide it by the thing you're factoring out to find out what's left inside the brackets here. Now, inside the brackets, I've got a polynomial, quadratic actually, with a leading coefficient of 1. So now I can complete the square on the stuff inside the brackets. And the stuff outside the brackets, I'll just copy down as I go until I've completed the square here inside. So to complete the square, first I need to take half of the coefficient of the middle term. And make sure you do this after you factor the minus 3 out or you'll get everything wrong. Okay, so you have to be at this stage first. Then take half of this term here, so that'll be negative 1, and call that capital B. So I just wrote it out, it's negative 2 over 2, so you can see where the negative 1 came from. So that's negative 1. Then B squared will be 1. Right? And then what I do is inside the brackets, I add 1 and subtract 1. I don't add 1 to both sides of the equation here because it's too confusing. There's a 1 inside the brackets that gets multiplied by the minus 3, and then I can't add a 1 outside the brackets because it would just be wrong. I'd have to subtract 3 out here, and that gets too confusing. So I just add 1 and subtract 1. In other words, I'm adding 0, but I need a 1 here to make this a perfect square. The trinomial here that I'll get will be a perfect square. But then if I add 1, I have to subtract 1 to balance it out. Okay, so I do that. I just add 1 and subtract 1. And then I take this trinomial and factor it. And that factors as a perfect square. Oops, I went a little bit too far there. Let's back this up to here. Okay, that's a perfect square. So this is this thing I've underlined in yellow here. When I factor that, I get x minus 1 squared. It's always going to be x plus b. b is minus 1, so it's x plus negative 1, so it's x minus 1. So this is x plus b, the quantity squared. That's this trinomial. Now I still have this minus 1 left, so I have to bring it down. Oops, went too far. Hit the wrong button. And I still have the minus 3 on the outside from here, and I still have this minus 1 on the outside of the bracket from here. So this minus 1 is this one right here, minus 1. This minus 1 is from here. So it's important to keep track of this. What I would recommend is, once you have listened to this example, go back and try to do it yourself, maybe keeping this by your side so that when you get stuck you can look at it and see what you're supposed to do, and then try to do it again without looking at it at all. If you get stuck, look at it, and just keep doing that until you can get through it all correctly and you understand what you're doing at each step. Okay, and then you can move on to other examples, do some practice on Hawks, do the practice and just look for ones like this that have a leading coefficient that's not 1, and that's, well, basically it's in this form here, this kind of form. And practice those, and you'll find that the numbers will change, but the procedure's the same for all of them. All of the ones with a leading coefficient that's not 1, that is. So now what I did is I just distributed the minus 3 across these square brackets to get rid of the square brackets. So I get a minus 3 in front of the parentheses. Don't try to put it inside. In front of the parentheses. So that's negative 3 times this first term on the inside of the brackets. And then I need negative 3 times the second term on the inside of the brackets. So it's negative 3 times negative 1 is positive 3. And then I just brought this minus 1 down. So now I don't have these brackets, so now I can combine this 3 with this minus 1. So 3 minus 1 is 2. And then you'll notice that that's in the same form that we had on the previous page. I've completed this square. And so now I can find the vertex by setting the inside here equal to 0 for the first coordinate, and using this for the second coordinate. The axis of symmetry will be what you get when you set this equals to 0, the equation, right? And then I can do all this stuff and graph it. It didn't say to graph, but the types of things they're asking for, I should probably graph it. So the vertex is 1, 2, 1, 2. The axis of symmetry is x equals 1. That's just from setting x minus 1 equal to 0. This x minus 1 equal to 0. You solve, you get x equals 1. The x-intercept, that's where, I'm sorry, I'm doing the y-intercept first. The y-intercept is where x equals 0. So you plug x equals 0 into the equation. You could do either one, this form or the original. For plugging 0 in, this is the easiest one to use because you just get 0 plus 0 minus 1. So y is negative 1. So the y-intercept is when y is negative 1. And then I think on Hawks they want you to give the x and y coordinate. So they define the intercept as a point on the real plane. So you need the x and y coordinate. The x coordinate I wrote right here. And I would write this exactly the way I just did. Say what you're computing, then compute it, then write the answer in the form that they want. Okay, then you want the x-intercept. And I always write this out because it's the opposite number that's 0, right? So then I don't make a mistake. So x-intercept will be where y is 0. And that's easiest to solve using this second form, this form here, where y is 0. Well, actually, you could use this. Well, let's see how I did it. Yeah, so I used this form because this form, see this form here has two different x's, so it's hard to solve for just one of them unless you can factor this easily, which it doesn't factor easily. This one here only has one x in it, so you can, when you set y equal to 0 here, you can solve for this x. So the first thing I would do is I would take this term, so this is two terms, this term and this term. I would take this first complicated term, move it to the left, it becomes positive 3 times x minus 1, the quantity squared, equals 2. Okay, then I would divide the 3 out to isolate the square part of this. So I get x minus 1, the quantity squared, equals 2/3. Then I would do the square rule, which gives me plus or minus square root on the right, and loses the square on the left. So I get x minus 1 equals plus or minus square root of 2/3. You don't have to, that's simplified, there's no perfect squares inside. So it's in simple form. You don't have to worry about rationalizing the denominator. Okay, and then I'm just going to add the 1 to both sides, and I get x equals 1 plus or minus square root of 2/3. So those are the x-intercepts. There's 2 of them. Sometimes there's 2, sometimes there's 1, sometimes there's none. The y-intercept, we always have a y-intercept for these parabolas, for the quadratic equations. Okay, so I just write out the answers. The y-coordinate, of course, is 0, and I just write out both of them as an ordered pair of numbers so that it's a point on the real plane. And what else did they ask for? Let's see, find the vertex, done. Find the axis of symmetry, done. X and y intercepts, done. Find where the maximum value is and what the maximum value is. So to understand that, I'm going to graph it. Since I've got all this information, might as well, right? There's the vertex 1, 2. Now, I'm going to go, my special points I could use, or I could use the x-intercepts. I probably use the special points, go over 1 and down 3, because there's a leading coefficient of 3, right? Or negative 3, leading coefficient negative 3. And you can read that from here or here, but notice it's the same. So I would go right 1 and down 3, left 1 and down 3, which happens to coincidentally give me the y-intercept. So you can see that turned out right. So some of this is checking my work too. So I get that and that. Okay, and then now I don't have to graph the intercepts because it didn't say to graph the intercepts. But the reason I drew this is because it says find where the maximum value is and what the maximum value is. And you can see that this curve maxes out at the vertex. And that's my point for drawing this. Now, that's because it goes down because of the negative here. If it went up, it wouldn't have a maximum, but they would probably be asking for a minimum value. If it curved up like this, that would still be at the vertex. Okay, so when they say find where the maximum value is, they mean the x-coordinate. So the x-coordinate of this is 1. X equals 1. Okay? So it's at x equals 1, the point, the number 1. Okay, and then when it says, what is the maximum, that's how high is it? What is the maximum, what's its maximum height is what they mean. And so that's going to be at 2. So that's the y-coordinate of the vertex. Okay? So just a little bit of language that you have to be careful of there, so that you get the right. So because usually they only ask for one of the two, and you have to know which one to give. Okay, like suppose that this graph, the horizontal was the amount of money invested, let's say, and the vertical is the profit. Then what is the maximum profit would be how high the graph is. When would we get the maximum profit? That would be how much you had to invest to get the maximum profit. So that would be the horizontal coordinate. Hope that helps a little bit. If you didn't quite follow that, just stick with what I said earlier.